Hello and welcome to this lecture. In this exercise, we have a small repository with an intentional bug plus a failing test that describe the expected behavior. The whole point is to let the parallel agents in anti-gravity do the triage fast, then you can pick up the safest patch and the approach. Hopefully by the end of the lecture, you're going to learn how to split a messy bug into 3 parallel tracks. 1. How to reproduce, 2. Root cause analysis, and then 3. The safest fix. You'll also learn how to use tests as the truth during the triage process. You'll learn how to review AI output like an engineer. So think of risk, scope, regression checks, and so on. And then, of course, a classic real bug pattern, which is state leaking across calls. Now, this is important because this is what teams and software development and software engineering is all about on a day-to-day basis, looking at issues in products and production. So think of this in terms of importance, that a report that drifts after the service runs for a while. That's one example. A job that looks fine on first run then starts overcounting is another example, and a bug that only shows up in a long running process. So think of workers, web servers, schedulers, and so on. Some of the real life use cases here could be incident dashboards that refresh every minute, ETL jobs that summarize logs in badges, on-call digest reports that must stay stable, or anything where the same input should mean the same output type of situation. Let's quickly explore the project files and see what's in the repository here. So if we go inside the source folder, we have another folder called Mission Control Demo. And if we're looking at the triage.py, this is basically the file that contains the core parsing plus the summarizing logic. So this contains the intentional bug over here in this file. So if you scroll, you should see a section with the comment over here. You see it says note, this is the intentional bug for the demo. The default dictionary is shared across calls, and this is the thing that we are actually going to hopefully try and get anti-gravity agents to fix. Now, going over to the CLI.py in the same folder, as this file is a simple CLI to print a digest from a log file. And if we go inside the assets folder, we have a file called sample log. And this is, just think of this as a sample incident log with some fake data in there for the purposes of this demo. And then going into the tests folder, we have several tests. We got the smoke test and the unit test. So these are the unit tests that are written, and these are the smoke tests that are written for the CLI. These are just tests that currently fail and explain what correct actually means. So they define the expected behavior. And then finally, going into the docs folder, we got the bug report.md file. And this is a short user reported type of this write-up to guide the triage. So again, imagine somebody found this bug in your product, they reported it, and this is the report that they wrote. So as somebody who's looking at this, trying to troubleshoot and debug the problem, you would come and read this to kind of understand what it is. So the symptom is described. Incident digest output changes if you run it twice in the same Python process. The impact, so on-call reports become untrustworthy, and then expectation. Here's the expected behavior, and then here's some hints like in terms of where you could potentially start looking at. So now that we have some tests that have the expected behavior defined here, let's go ahead and run this. And of course, at first glance, we do anticipate them failing because we do have an intentional bug. But let's go ahead and actually launch a new terminal here, create a virtual environment for Python, and then we'll run the test to see what our starting point looks like. Okay, let's go ahead and activate that virtual environment. And now we'll install the dependencies from the requirements file. All right, so the dependencies from the requirements.txt file have been installed. However, we do have a project.toml file as well. I could have just put this in here, but I haven't, so we can just go ahead and individually, I could have just thrown in a -e space here, but because we don't have that already, what we can do is, let me actually undo this, and we can just go ahead and just run that in here. So pip install -e dot, and this will install the dependencies from the project.toml file that are mentioned over here. Okay, so now we have all the dependencies installed and we're ready to move forward. So just to recap, we are going to triage a bug using multiple agents in parallel using anti-gravity IDE and agents. In this demo, this repository prints an incident digest from a log file. The bug report says the output changes if we run it twice in the same Python process, as we saw in the bug report.md file. So first, I'm going to prove the bug exists by running the test, which is what we're going to do right now. Then we're going to spin up 3 agents, one to reproduce and summarize the failure, one to find the root cause, and one to propose the safest patch. Then we'll go ahead and review what each agent returns, pick the safest fix, apply it, and rerun the test to confirm we're green. So again, the key idea here is speed without guessing. So every change is tied to the failing test and a clear risk check that we're going to take a look at. So let's go ahead. First things, let's go ahead and run the test. So I'm going to do that by using pytest-q. All right, so it seems like a couple of the tests have passed, one of them is failed, and this is exactly what we expect. So you see the auth4 versus auth3, so there's a mismatch, and that's why the test assertion is actually failing. Now, looking at this failure is exactly what this demo is supposed to start with. So we are seeing the correct thing. And what the test is proving is that if we jump over to triage.python file, which is our main, and if we find the function called build_digest, let's scroll down here, this one here. So build digest function takes in a text argument that's going to be a string. This build digest function should be pure, which means same input, same output. And looking at this and the diff, it shows the counts change between call 1 and call 2. So for example, you saw in the error, you saw auth4 and auth3. So auth4 versus auth3 here, which almost always means some state is being kept across calls and not reset. So in plain terms, this means something inside the digest code is reusing a dictionary, counter, list, or a cache from the previous run. Some of the common causes that could potentially result in this outcome. Again, we're not saying this is it, but just from experience, some causes could be a module level variable like the counts list that gets mutated, a mutable default argument like the build digest, and a helper that stores results in a global scratch object, for example. These again could be just some common causes, we don't know, but we do know that something inside the digest code is reusing something that perhaps is not from the previous run, which it should not be doing that. So we are seeing the error, and this is exactly what we expect. And then the next step is for us to triage, troubleshoot, and put in a fix. Next, while we're in the terminal, we can also run the CLI. So let's go ahead and do that, and that's against the sample.log file here. So I'm going to do that by the following command, python-m, and then the mission control demo.cli, and then we got the digest -- and then the sample log file. So let's go ahead and run this. We can now see the result from the CLI command in the console. So we got the total lines 5, which is exactly what you see in the sample log. In terms of errors, we got 3, so 1 auth error and 2 payments, and these are the errors associated with them. So for the card one, it was card declined. We got 2 errors, and then invalid password 1 for the auth error here. Now let's switch our focus into coming up with a solution for this. And the following is going to be sort of like a do it one pass flow. or do it all in one pass flow so that we don't need to manually guide each agent beyond the prompts. And this is one of the places that anti-gravity really shines in. So if you already have this open, you can start putting in the prompts on the right hand side here, depending on planning or fast. Planning means agent can plan before executing tasks, so you can use that plan. Or if you just wanted to dive into the execution directly, you can select fast. I recommend planning because that way you get a chance to actually review before accepting the results there. However, we can also do things in the agent manager view, which is the one that I prefer because that's the one that we can launch multiple here as well, like while reviewing things as things progress. So again, in order to get into this, you can just Command E or Control E, and that would launch the agent manager dialog. And this is where you would have a very focused view of just dealing with agents from anti-gravity. And one note is that remember, whenever things are finished, you can go into the inbox here, right? So whenever the agent's done, this is from some of our previous demos. You can see that you can actually view the results when they're done, and then you can click on open, and then you can review them. So just remember that this option's here in the inbox, and you have the report there. Now, going back into the conversation, so going into the workspace again, over here, we have the, this is again from some of the previous ones, so we'll start a new conversation. This workspace is from the previous demo. Here we are on the, right now we're in demo 4.2, so we want to be in 4.2 over here, workspace. So this is the place that we want to be in. So if I click plus start, you can see that this is going to start a new conversation in the demo 4.2 workspace, which is the demo we're currently on. All right, so now that we ensured we're in the correct workspace, which gives the agents right context in terms of repository, code base, and the files it needs to dive into, we can go ahead and get started with the first agent. So again, agent A is in charge of reproduction or reproducing the issue. So this is the prompt that I'm going to use. You are agent 1. Again, repro means steps to reproduce or reproducing the defect. Goal is to reproduce the bug and summarize what is failing. And then here are some steps that I've included. So run pytest-q and paste the failing test names and key assertion messages. Identify the smallest reproduction in terms of which functions or calls or triggered the drift. List the two files most likely involved, and some other guidelines like suspected files, minimal repo, bullet points, and things like that. So what I'm going to do is I'm going to run this here. So let's go ahead and run that prompt, and then this will be agent, basically agent 1 at work. Then we can go ahead and start a new agent, and this is going to be agent B, and this person or this agent is involved for the root cause analysis. So I'm going to put in the following prompt. Note that agent 1 is still processing while we're creating agent 2. This one says you are agent B, so root cause, read the failing test and the suspected files. Goal, explain exactly what the output drifts across repeated calls, requirements, point to the specific lines causing the shared state, explain the mechanism in plain terms, and so on. So the fixed plan, and then the risk and the root cause analysis. So let's go ahead and run this. And then lastly, we want to come up with the safest solution or a patch. So this is where I'm going to start another one. So this is agent C. And says your agent C, which is the patch, implement the smallest safe fix that makes all the tests pass. Here are the rules. Do not change test expectations. Keep behavior the same. Keep output deterministic. Here's the deliverables. So a unified diff patch, commands to rerun the test, short note explaining what changed. So let's go ahead and run this as well. Now we got 3 agents running in parallel, trying to get the work started. Let's hop over to this one. The blue means it over here, we're done, and we can actually review the steps. So this was the bug reproduction. This was agent A, which we prompted, and it's analyzed the results. Again, you can click on this and it will show you the thought process. And again, you can expand this. But here we're just looking at the high level summary. So it says reproduce bug. The previous attempt to run py failed because the command was not found. So this is a different command. I am now attempting to run pytest or python dash and pytest. I'm also exploring this. And then over here, it was able to run some of the tests. So it says once it figured out how to run the test, and this is the nice thing about agent because we don't need to interfere, it can just try things on its own until it gets it working, and it got the command and running the test working. Once it did get that working and ran the test, it says this one the actual test fails with the assertion error. The second call to build digest includes counts from the first call. So example auth 4 instead of auth 3 if run twice, which is what we saw in the console as well. And it says this one here in the CLI smoke, this was the unit test. These were the CLI smoke test, fails because the CLI output is not stable across two invocations. Minimal repo steps in terms of bullet points. Import this, create a list of events, and then call the function once, call it again, and then observe the second call returns counts that are double the expected value. So it is telling us exactly what to do. So this is essentially doing what a tech support person or a QA engineer would do. Basically going through the repo steps and then create, you can even create a ticket in a project management tools such as Jira, and you can put some of these steps to reproduce in there. Of course, this is not formatted nicely, but you can ask the agent to get it in a format where it's very suitable for copy pasting into those systems. And then it says suspected files. These are the two files, triage.py and the unittest.py are the suspected files that we need to fix. Let's now hop over the other one. This is agent B, and this was the agent in charge of root cause analysis. So again, it's analyzing and it's running the test. You can see it over here. It actually failed. It says agent terminated due to error. Let's go ahead and retry to see what happened and see if it can figure things out. Excellent. So it looks like it was able to run on the retry, which is great. Again, didn't really have to do anything other than clicking the button in this case, and it retried on its own and it was able to figure out. So if we scroll down here, you can see it analyzed the failing test. It has the sort of progress updates here. If you wanted to expand, you can look again through its thought process and what it did. But looking at this high level, investigating failing test and code base, running the test via venv, finding test files, reading failing tests and suspected source code, examining source code for root cause. Then here we can see the analysis. So identified the root cause, mutable default argument in triage.python file, verified no external usage, relies on this side effect, now creating implementation plan to fix. And then looking at the implementation plan, which is in the right hand side of the screen here, it kind of goes through that. And then if you look here, again, I have identified the root cause for this output drift. The function summarize error by service in mission control triage.py uses a mutable default argument, counts. The dictionary is created once at definition time and shared across all calls, causing error counts to accumulate indefinitely, which is exactly the issue, as we were aware. And then the fix plan is I will modify this to use none as the default value and initialize the dictionary inside the function. This ensures a fresh dictionary is used for each call unless one is explicitly provided, which is great. So now we're not stuck in that state so that on every call it's going to start with a fresh one here. And then the risks, external dependencies, API chain. So if I remove the argument entirely, it would break callers passing it in. So this is something that you need to be aware of, right? So for the purposes of this demo, though, let's say we don't have any API change or any dependencies, and it's just used internally in our code base. So it says implementation plan. I'll go ahead and proceed with that. And now it's going to generate that for us. And while that's going, let's go ahead and take a look at the fixing output drift bug. Looks like this one is the implementation. So this is the agency in charge of doing the implementation and patching the fix. And it looks like it came up with the results, the correct results, I should say. I have identified the issue and created an implementation. Please review it. Now, the thing is, in this case, it's what we've done is a little bit redundant. Again, I just want to show you the idea behind not just what agents can do, but how you can leverage the multi-agent infrastructure in Google's anti-gravity to speed things up and get assigned different roles and responsibilities and execute jobs and tasks in parallel for those roles and responsibilities. But in reality, we don't really need three agents here. Technically, we could have done everything in one agent, or perhaps two, having an agent finding out the root cause and then having an agent doing the actual patch is a bit redundant because you can have one agent figuring out the root cause first by diving through the code and figuring out the issue, and then propose the same agent propose the implementation fix. That's the way I would normally do it, but I did want to demonstrate the functionality around running agents in parallel, which is very powerful here in this ecosystem. So if we go back, before we actually proceed, if we go back here to what this was again, agent B, if we scroll the root cause analysis, now that it has finished, it kind of created the, again, the walkthrough for us. So if you open this, you can see it is proposing the change. It's not going to make the change, it's just proposing the change. And the walkthrough fix here, it says I fixed a bug with the incident digest output with the drift across requested. Here's the changes. So actually, if we go to the this file here, triage.py, review changes, you can see that it has made some changes to the file. So again, this is kind of like it's where we have to come in as the person who reviews the change. And basically, again, you can see that setting that to none to start with, actually over here during definition time, it sets it to none. And then for each function, it actually fixes it. So it starts with the fresh one. So it is correct. Basically, exactly what it said is changed. So again, you don't need multiple agents to accomplish this. You could have done it with just one or perhaps two, but just wanted to demonstrate that. And then if let me go ahead. So this was in, if we go back one, the walkthrough plan was in triage.py, and this over here, this function summarize errors. So if let me move this over, and then if you go back to the IDE, which again, of course, you could have just done that by clicking this button here, open in editor. This would show you the same thing, but let's go ahead and triage. You can see that agent B has already made the changes to the file. The diff is there for your review, and then you can simply click accept change. So again, in theory, we didn't really need agent C. So if you go back, let's just go back to agent C though, just to make sure we review its fixing the output drift. This is agent C. Agent C also came with basically did the root analysis, and it says I have identified the issue and created an implementation plan. Please review it. So you can click on open, and then you can click on proceed, and then it will make the changes. So fix a bug where this one shares state across calls due to mutable default argument, and then propose changes, modify triage.py, change the default value of counts from this to none, and then initialize counts to this inside the function if it's not. So let's go ahead and proceed. And now it's going to make changes. Now this is unnecessary because the other agent actually made the change into the file. So we'll see how these two play, if they play nicely, but essentially the changes are already there. You can see that it did run into errors, and that could potentially be because the changes from the other agent are already in the file. So this one might have a little bit of a difficulty because by the time it goes to apply the changes, that file has already been changed and there may be some conflicts there. All right, so this agent now finished processing, and it says I fixed the output drift bug by resolving the mutable default argument issue in triage.py. So let's go ahead, and if we open the thing, it made some changes here, and we could go to review. Again, if you want to submit any comments, you can here. You can select this and submit comments, but essentially it proceeded with the implementation plan. And what we can do is now let's go back to the code editor. And if we go over to triage.py, you can see that it, if we go back here, Actually, let me just go ahead and close this just so that it's easier to see. And again, if we go back to the walkthrough here, you can see the changes that were made in that file was in this function, and then it changed this to none, and then we introduced the one in the function call. So if we go back to the triage, let's find that function here, scroll down. This is the one. So this was the change that was made. Again, remember from agent B, we could have accepted changes, but agent C just went ahead and applied the change because that's what we asked it, just apply it. So we didn't need to interfere and review the changes and simply ex, you know approve or reject the change because we read the plan and we are happy with it. So we did ask, just go ahead and apply it. So here you can see that, and then here's the change here that fixes this bug here. So the rest of this is fine. Looking at CLI, this is good. Looking at the CLI smoke test, this one is good. And looking at the unit test, this one is good as well. You can see it says test digest is stable across 2 calls. So essentially this should help verify the fix once we run the test. So always remember this when you're reviewing, and treat this as your checklist when you're reviewing the changes from the agent. So think about these questions. Does this fix change the public output format? The answer should be no. Is the fix scope to the bug? The answer should be yes. Do the test cover the bug? The answer should be yes, and in this case, they do. And then when I rerun the test, should they pass? Well, the answer is yes, they should, because now we put in the fix and the test also uh, resembled the expected behavior. So now that we have our checklist and we've gone through it and we're happy with the results, the only thing left is for us to go ahead and run the test to ensure everything's passing. So let's go ahead and do that. Going to launch a new terminal. I'm going to type in pytest-q. And now, as you can see, all 3 tests are passing. Now, one other test we can run is we can run the CLI twice, and this should be a quick proof for us. So let's go ahead and do that here. I'm going to paste in this prompt. I'm going to run it, and you can see it says, again, total number of lines 5, errors by service auth 1, payments 2. I'm going to rerun this again. And you can see that we get the same results here. So we get 5 auth 1 payments 2, and this is actually good because before we fix anything, I wanted to prove that this isn't just a picky unit test, and I wanted to run the CLI command twice with the same log file. So if the tool is reliable, the digest should match exactly both times. If it doesn't, that means we have state leaking somewhere, like a global counter or a hidden cache, and the output can be trusted for incident reporting. So let's run it. That's why we just ran it twice, and then we compared the output, and you can see here this is great. This is why determinism matters. Same input should always produce the same output, or you can't rely on the tool in production.